Hello, today we'll be analyzing the wine data set. We are going to focus on correlation between the variables, and then we will look also into creating a linear regression model where we are going to predict the price of the wine using these inputs here. So this is how the data looks like. We have the year column, the winter rain, average growth, season temperature, harvest rain, age, and France population. So this wine is from France, and it's in 1983 that it was collected. You can get that from 1952, the year wine was made, and the age of the wine. So if you add them up, you will get the year. Any NA will give us if there is information, if there is any missing value in the data. There is none, that's great. We can also use this is NA and then sum it up. We can see there is none, so that's again great. We can do some quick checks with the relationship between the different variables and price. So I started here looking into the relationship between winter rain and price. It seems a bit more scattered around, so it seems winter rain is not that important, but we changed it to AGST, which is the average gross season temperature. You can see there's a much more correlation going on there. By adding this geom smooth with method LM for linear regression line, we can see that blue line being added to the plot. So that shows, basically this plot shows a simple linear regression model, right? Because we are using just the AGST as input, and then how the relationship between price and AGST is there. We are setting SE false because if you don't do that, it sets up the confidence levels around here. We don't need that for now. Correlation, we can use the base correlation function, which is core, which will give the correlation between each and every variable there, as you can see. The easier way to work with that, of course, would be to create a correlation plot, right? So we will install a package for that. It's called a GG core plot. Let's install this, and then we will call it in. All right. And now let's use the GG core plot, which within the GG core plot library, they share the same names. And as input, I'm giving the input of the correlation of the wine data set. Right, not the wine data set directly itself, but the correlation between the different values. We run this one. You can see the correlation plot being shown to us. So red means +1, strong positive correlation, and dark blue means -1, strong negative correlation. And so this is how the correlation within this wine data set looks like. So some quick things like this: age and year are negative, very strong correlated, right? Because as you imagine, a year increases that the year of the wine was made, then the age will decrease, right? It will become younger, basically. So that's why there's a strong negative correlation between those two variables. As the year increases, it seems like the France population seems to be increasing as well. So that's another strong correlation there. In this case, it's a positive correlation. The diagonal is not important because it shows the correlation between the variables among themselves. So year versus year, it's always going to be +1, right? For the same variable, price versus price is going to be +1. So that diagonal there is not providing any value. So that's why to create maybe a nicer plot where we don't see that at all is to add this variable parameter called type here. So let's say type is equal to lower. Run this. You see it only shows the lower portion, so it gets rid of all this upper portion because it's mirroring itself, by the way, along this diagonal. It's another thing you might have realized. So we only need to see either the upper portion or the lower portion. If you say type lower, then we are going to see only this part, and this should be more than enough for us. All right, now let's start building our linear regression models. linear regression. So we will start with simple linear regression, meaning we are going to start with using a single variable. The model is the name I'm going to give for my model here. So if you say LM, that's used for linear regression, and then I'm going to provide the formula. Let's start with winter rain. Although I know that winter rain seems not very good, but I want to start with that and add more variables later on. So you give the dataset name after that. You say data is wine. If I run this, let's call this model 1. Let's run this. Okay, so if I now check model 1, it will not nodal, it's model 1. All right, so it shows the coefficients of these variables. If I want to see more information, I can use summary, and within summary I'll provide model 1 there as the object. So it shows the formula. So price is predicted using winter rain. This is the tilde sign. It's on the top left of your keyboard above the tab key. The price is predicted using winter rain. These are the coefficients of these two. So the intercept is 6.66. Winter rain is 0.0006. At the very right, you see the p-value. So the p-value for winter rain is 0.5, which is not significant. So this model also confirms that winter rain is not a very good variable to use, actually. You can also tell us from this, the multiple r-squared value, which is the r-squared value, is 0.01. Basically, there's a very tiny bit of an increase in the model's capacity, you know, in learning from the data by using winter rain, right? And actually, if you look at adjust r-squared, is even negative. So basically, adding this variable is not really doing a lot of good things, other than a very, very tiny bit, maybe. Okay. Create another model. So I will take all these, and I will name the new models model 2, model 2, model 2, and model 2. And as input, I will always keep price as my prediction because that's the output value variable. I want to predict that. But as input, I want to change this. I want to change this to, let's say, harvest rain. How does harvest rain perform? Okay, let's look at the summary. So harvest rain has a negative value, actually. That means if the harvest rain increases, it will actually decrease the price of the wine. So harvest rain apparently is not good for wine to happen, right? So it's not a good thing to happen. There's a negative value. We see that from here. And it's also significant. We see that from these 2 stars as well. The multiple r-squared value is 0.31. So this one on its own is doing much better compared to winter rain there. And let's create a final model here. I suspect AGST is also important. I'm not sure whether it's more important than harvest rain. We will see that soon. AGST as input, 0.63 is its coefficient. Okay, so that means AGST is a good thing, right? If AGST increases, so the growth, average growth season temperature, if it increases, the price of the wine is also increasing, right? And you can tell from this model that for each unit increase in AGST, the price of the wine will increase by $0.63. That's what this coefficient means. The intercept is basically on its own is the starting point. So if the AGST is 0, basically the temperature is 0, starting point of the wine is minus $3.41. So okay, that doesn't really make sense, and you should not always try to make sense of the intercept. Okay, intercept is there in the model. We don't really care about it too much. Sometimes it might make sense to values, but again, for example, for this one, starting point doesn't really make sense. And that's because from the data, let's have a quick look at the data. Wine. So the temperature is around 16, 17. So the model is basically learning from this, right? It's not really seeing any data point showing 0 degrees. So that's why we should not even consider thinking about the model of what would happen if the temperature is 0. Although we could, but it's outside of the range of our data points, because the data points might be totally different at those temperatures, right? So the model basically learns from these data points. So around these temperatures, this is what the model builds, right? So around 16, 17 degrees, if you multiply that by 6.63, and then basically subtract this value, that's kind of your starting point there. Because that's one issue that you should always know in machine learning in general, and especially linear regression in particular. You should only be concerned about the data points that are available to you and stay within that range. If you try to extrapolate outside of that range, you're not doing a good thing. You're doing something wrong there. Okay, so that should not be done. All right, the AGST coefficient is also significant from the p-value, and these 3 stars here, we can see that. Right, so we have built simple linear regression models here. I want to show you how to do prediction now from using this coefficient. So if you go with this model, right? So the coefficients, if I take these coefficients, I can write my linear regression model here. I can say minus 3.41 plus 0.6351 times AGST is my model. What does this mean? It means if my AGST is 10 degrees, well, let's stay close to our range. AGST is 15. I can take this model here and I can make prediction, right? Instead of AGST, I will now write 15 if I run this. So the price of the wine will be predicted to be 6.11 with this inputs. Okay, I can take these coefficients rather than copy pasting, and take these inputs directly from the model. So what I can say is model $3. If I say coefficients, as you can see, it gives me the coefficients back. And I will put these into something called as numeric. I will just take these numeric values out of them, right? So I can save this into something called coefs, let's say, for coefficients. All right. Now the first value was the intercept there, and the second value is the coefficient for AGST. So I can set up my model. I can say coefficients 1 plus coefficients 2 times the AGST value, right? So instead of AGST, now we said what's the price of the wine at 15 degrees. If I run this, I get 6.10. There is a slight difference. The reason is these are exact values. You see, they are much longer. But here I kind of rounded them up. So I just, this summary output doesn't show all the numeric values here. So it's a bit rounded. So that's why there's a rounding difference there. But the difference is not very significant. So the price is 6.10 basically, or 6.11 if you round it up. Okay, so that's how you can make predictions, basically, and making use of these coefficients. That's what it means. As I said, each unit increase in the AGST value will increase the price of the wine by 6.63. That's what this coefficient means here.